Welcome to David Alexander Maths Tuition. This is chapter 11e, Integration by Substitution. Okay, so here's the first example. Use the substitution given to find the integral of x square root of 3 plus x dx, and we know that u is 3 plus x. So the first step with these sorts of questions is, first of all, to do a du by dx. So all we are doing is differentiating this. So if u is 3 plus x, then du by dx is, now what is the derivative of 3 plus x? That is just 1. Now in this equation we've got dx. Now we want to change that to a du. So if du divided by dx is 1, then that means that du equals dx. So what I'm going to do is I'm going to replace this dx with a du. Okay, so we need to also substitute x. Now if u is 3 plus x, then what that means is that u take away 3 is x. So I'm going to replace that with a u minus 3. And the square root of 3 plus x, well, we know that 3 plus x is u, so the square root of 3 plus x is u to the power of a half, and that is du, because remember that dx equals du. So all I'm doing is I'm replacing all the x's with some u stuff, and I'm turning dx into du. So all I need to do now is integrate u minus 3 u to the power of a half. So first of all, I'll expand the brackets. So that is going to be u to the power of 3 halves minus 3 u to the power of a half du. Now, just remember, we haven't actually done any integration yet. So as ever, we're just going to increase the power by 1. So that's going to be u to the power of 5 over 2, divide by the new power. So that's going to be 2/5 u to the 5 over 2. And do the same with the other one. So u to the power of a half becomes u to the power of 3 over 2. So 3 divided by 3 over 2 is the same as 3 times 2 over 3. So it is 2. So take away 2 u to the power of 3 halves plus the c, of course. Now all we need to do now is just remember that the original integral was x. Well, what we were originally integrating was x root 3 plus x. So we now just going to turn it back into x's. So u is 3 plus x, so that's going to be 2/5 of 3 plus x to the power of 5 over 2. Take away 2 lots of 3 plus x to the power of 3 over 2 plus the c. Use the substitution given to find cos cubed x dx, u is sine x. So exactly the same as before. If u equals sine x, then du by dx, let's differentiate sine x, well that is cos x. Now we want to replace, what's another way of stating dx? Well, du over cos x is dx. Okay, so I can't replace cos cubed x with any u's because u is a sine x. So let's just see what happens if I leave the cos cubed x in there and just replace the dx with a du over cos x. Well, we can see we've got a cos x on the bottom and cos cubed x on the top. So that will, the cos on the bottom will cancel with one of the 3 cos's on the top. So that will be cos squared x du. Okay, so now I need to write this in terms of u. Now I know that cos squared x is 1 minus sine squared x. And if u is sine x, then that means that u squared is sine squared x. So what I'm integrating is 1 take away u squared du. So now I can integrate this because we've got a du and everything is in terms of u. So that would be u minus 1/3 u cubed plus c. And remember, u is sine x. So the integral will in fact be the sine of x minus 1/3 sine cubed x, or sine x all cubed, plus c. And we're done. Okay, so here's a slightly new question, new style, where we are working at a definite integral. So we're going to do exactly the same thing as before, which is we're going to do our du by dx and substitute x with u stuff, and substitute the x plus 2 to the power of 5 with some more u stuff. But first of all, we've got these x limits here. So we're going to change these x limits into u limits. Now, if x is 3 and 0, then u is 2 added onto these. So the u limits will be 3 plus 2, which is 5, and 0 plus 2, which is 2. So first of all, we're going to change the limits to 5 and 2. X is u take away 2, just rearranging this equation. And x plus 2 to the power of 5 is u to the power of 5. Now dx we need to replace with du. Well, if u is x plus 2, then that means that du by dx is 1. So therefore, du equals dx. So that's an easy substitution here. We're replacing dx with du. So let's expand out those brackets. We're going to get u to the 6, take away 2u to the 5. So increase the power by 1 and divide by the new power. The integral of u to the 6 is u to the 7 over 7 minus 2u to the 6 over 6, or 1u to the 6 over 3 if you like. And that is between the limits of 5 and 2. So so here we don't need to return these u's back in. Well, we could do if you wanted to. We could replace u with an x plus 2 and use the limits of 3 and 0, but it's a lot easier keeping it in terms of u and using the u limits. So what is 5 to the power of 7 divided by 7? Of course, it's something fairly horrible. So 7, 8, 1, 2, 5 over 7. Take away, so 2 multiplied by 5 to the power of 6 divided by 6. So that is 15625 over 3. In fact, I'm just going to work out what I'm sort of running out of space here. Let's just do the 7, 8, 1, 2, 5 divided by 7. Take away that answer that I just had on the calculator. So that was still fairly horrible, of course. So 125,000 all over 21. Take away, right, let's put 2 through this function. So 2 to the power of 7 divided by 7, that is 128 over 7, slightly more reasonable numbers, fortunately. Take away 2 multiplied by 2 to the power of 6 divided by 6, which is 64 over 3. 128 over 7, take away 64 over 3 is negative 64 over 21. So in other words, we are adding these two together. So 125,000 over 21 plus 64 over 21, and we're getting our final answer of 41688 over 7. There we go. Now, what you probably would do, is, certainly if this was an exam question, to make sure you've got it right. Well, let's just see what that is as a decimal. It's 5955 approximately. Now all you need to do is type this in using the integration button on your calculator. My calculator will think about it for a while before it finally gives me the answer, and yep, it's exactly the same. In fact, it's given me 41688 over 7, so it's great when you can check that you've got them right, and in this case we have. So here's another example of a definite integral using the integration by substitution method. A bit trickier this one because we are dealing well, with a trigonometric one. So first of all, let's change the limits. So the x limits are pi over 2 and 2 pi. So therefore the u limits are, well, what is the cos of pi over 2? The cos of pi over 2 is 0. And what is the cos of 2 pi? The cos of 2 pi is 1. Okay, so the limits, the pi over 2 and is 0 and the 2 pi is 1. Does seem a bit odd that the larger one is on the bottom, but let's see what happens. So now we're just going to do our usual du by dx. So du by dx is negative sine x. So therefore, what is dx? Well, dx is going to be du over minus sine x. So what we've got here is we've got sine x. We've got the square root of 2 cos x plus 5, and we know that cos x is u, so that is the square root of 2u plus 5, and we are multiplying that by du over minus sine x. So I've got a sine x top and bottom, so that takes care of that at least. There's no substitutions needed there. But what do we do with this minus sign? Now, if what we're integrating has got a minus sign, well, there's two things we can do. Either we can just take the minus sign outside, or we can swap the limits. So by getting rid of this negative sign, I can change the 0 into a 1 and the 1 into a 0. So let's just tidy this up a little bit. What we are doing is we're integrating between the limits of, or the u limits of 1 and 0, 2u plus 5 to the power of 1/2. Okay, so we need to integrate this. So I'm going to use a guess and check method. So let's just experiment with 2u plus 5 to the power of 3 over 2. Let's check this out. So 3 over 2 comes down to the front. lots of 2u plus 5 multiplied by the derivative of 2u plus 5, which is 2. So that's going to be 3 lots of 2u plus 5. Right, well, we only wanted 1 lot of 2u plus 5, so the integral was 3 times too big, so we want a third of it. So what we have here is 1/3 of 2u plus 5 to the power of 3 over 2, between the limits of 1 and 0. Okay, so what happens when we put 1 through this? So 2 times 1 is 2 plus 5. 5 to the power of 3 over 2 divided by 3. That comes to 6.1734 approximately. Usually in an exam you'd not get a decimal answer. The question would have been done in such a way that you're getting a fairly nice fraction, or maybe not a nice fraction, but a fraction anyway. Let's put 0 through the function as well. So 2 times 0 is 0, plus 5 is 5. 5 to the 3 over 2 divided by 3, that is 3.72. And by subtracting the 3.72 from the 6.1734, I get a final answer of 2.4466. You can round it however you want, unless it's stated in the question how they want it rounded. And again, as a final test, I'm just going to stick this into my calculator using the integration button, and do I get 2.4466? If I do, I know I've got it completely right. If I don't, I know I need to attack the question again, and it is 2.4466, so we're all good. Okay, this is a challenging question. Again, this is very much the sort of question you could get in an actual exam. Quite a complicated one, loads of places where it's easy to go wrong. So first of all, I'm going to do the usual differentiation of the u squared equals e to the x plus 5. So here it's going to be implicit differentiation, so that's going to be 2u du dx equals e to the x. And again, if I just switch the e to the x with the dx, I get 2u du over e to the x equals dx. So I'm going to replace dx with this stuff here in a moment. Let's also work out our limits. I'm just mindful of space here. So the x limits are ln 11 and ln 4. So what is that in terms of u? Okay, so I'm substituting ln 11 into this equation up here. So e to the power of a ln 11 is 11. 11 plus 5 is 16, so square root it, I get 4. E to the power of ln 4 is 4. 4 plus 5 is 9, square root that, I am getting 3. Okay, so let's just write this down here. So the limits are now 4 and 3. E to the 3x is a little bit nasty, so I'll just leave that as it is for now. All over e to the x plus 5 we know is u squared, and that is going to be multiplied by 2u du over e to the x. Okay, so some relatively easy things we can do here. First of all, we can cancel out this u here with one of the two u's there, so I'll just get rid of that squared sign. Now e to the 3x divided by e to the x, well, that is e to the 2x, so I'll turn that into a 2, and that is gone. So let's just write this again a little bit more neatly. Between 4 and 3, we have 2e to the 2x all over u du. So we've nearly got everything in terms of u, but we've got this pesky e to the 2x. So we know that u squared take away 5 is e to the x. Now, e to the x multiplied by e to the x is e to the 2x. So what that means is e to the x squared is e to the 2x. So therefore, if e to the x squared is e to the 2x, then I can replace e to the 2x with the square of u squared minus 5. So that's going to be 2 lots of u squared to take away 5 squared all over u. Okay, so let's just expand out these brackets. I'll just keep the 2 on the outside for now. So that's going to be u to the power of 4 minus 10u squared plus 25 all over u. And for this next part, I'm going to expand the brackets by 2, but at the same time, I'll just do 2 things at once. I normally tell my students only just do 1 step at a time. I think we can cope with this here. So 2u to the 4 over u, that is going to be 2u cubed. 2 times 10u squared over u, that is going to be minus 20u. And we've got plus 50 over u. Sorry, I missed out the du here and here. and also here. So this is what we need to integrate. So increase the power by 1 and divide by the new power. So that's going to be 1/2 u to the 4 minus 10u squared plus 50 ln u, and that is between the limits of 4 and 3. So all we need to do now is just be really careful with our substitutions. So 1/2 times 4 to the power of 4, that is going to be 128 minus 160 plus 50 ln 4 minus 81 over 2 minus 90 plus 50 ln 3. Okay, so I am running out of space here, but if we do 128 minus 160 minus 81 over 2 minus negative 90, or in other words plus 90, we end up with 35 over 2. And we've got 50 ln 4 take away 50 ln 3. So when you're subtracting one log for another, you can combine them using the division law. So that is 50 ln 4 over 3. So plus 50 ln 4 thirds. Okay, so we know that A is 35, B is 2, C is 50, and D and E are 4 and 3 respectively. However, I'd be insisting on just checking out what this is as a decimal, and as a decimal that is 31.88. And then testing on my calculator, just type this in, a bit of a fiddle to type in. Do I get 31.88? If so, fantastic. If that's not correct, then there's been a mistake somewhere, maybe not a catastrophic mistake that's going to mean you're going to get 0 marks, but it certainly alerting you to the fact that you need to go back, have a little look somewhere, pick out your error, and if you're going to hit 31.88, then you know for sure you've got, I don't know, 8 marks out of 8 or whatever it is. So in this case, we definitely do get 31.88, so we're getting 4 marks on this question.